now. I'm going to start recording the session. Okay, so we are recording. All right. So let me here kind of lay out. Then we can go back to Brightspace and just show you where all the materials are. But here we go. So this lab, the next topic that we're going to talk about is intrusion detection systems. Okay. Or as sometimes it is known, IDS, or sometimes network intrusion detection systems, right? And we're going to then learn what these things are. But basically, as you might imagine, this is nothing more than a sniffer, right? So the first thing that any intrusion detection system or any firewall needs to be is it needs to be some kind of a sniffer. But obviously now, whenever you grab the packets, you're going to do something with these packets, right? So that's what we're going to explore. So to keep things simple, we have two approaches, right? So we have two approaches that we could take. One of them is, of course, we could build our own intrusion detection system, right? So we could take, try to build an IDS, and we could use the code that we learned already, right? So we could use the LPCAP in C, C++, right? And you go to work for a company that wants to build an IDS, you would do that. You could build your own prototype of an IDS with Python, etc. The other approach is, of course, that we don't build it from scratch, and instead we just use one, right? So we need to get an IDS then, instead of building one. So for now, we're not going to build one. So we're not going to go into writing the code for a sniffer. Later on, when we look at firewalls, we will look at a little bit more code, but not for this one. Instead, what we're going to do is we're going to use an already existing IDS. And in particular, we're just going to use a Linux one. So we're just going to take an already established Linux service, okay? An already established Linux service for intrusion detection. So for this lab then, since this will be our approach, we're going to have to think of how this should work, right? Okay, so so let's go ahead here, and now let's think about, first of all, remember with the course, with all these problems, you should always think of a network, right? And a lot of students were really good at this, of just writing in their labs, what the network should look like. So let's say, for instance, you have an IDS, right? So let's think about it. You have an IDS, you have some network. And again, you're just going to think of a client and a server, basically. But you have some kind of an intrusion detection. You have a network tap in here. And so you're always going to have like an IDS, okay? So you have some device that needs to sniff on the network. It needs to capture the packets, and it needs to do something along those lines. So remember, that's why, that you already had a lot of practice in the previous labs about this, okay? So now we are going to need one Linux server to be just for intrusion detection, right? So you're going to need one just for intrusion detection. In theory, you would want to have an attacker also somewhere in the network, let's say. But yeah, I get that this is a lot of machines, right? So this is 4 computers. This is why when we do this class in the lab, we have all these physical computers to make this setup easier. Virtually, you'll have to maybe work with a few less. But certainly, you will need one dedicated machine to be your intrusion detection system. And I'll talk a little bit about that, give you the commands, etc. And then, of course, you're going to need to do some attacks, right? So obviously, what an intrusion detection system is basically a sniffer that captures packets. It usually checks some aspect of the packet. Believe it or not, about 50% of what they look at is the payload of the packet. And so they're going to look at that payload and say, okay, I know this payload, all right? Because we're going to see that there are, in fact, easily three different types of intrusion detection systems. We'll see that in the lecture. The very first one that we're going to focus on is what are called signature-based. And these are actually very similar to how, I mean, they work in a similar way, not 100% similar, but they are a little bit similar to antivirus scanners, malware analysis, right? So they're a little bit similar to that. So basically, the sniffer of the IDS captures the packet, breaks all the headers, looks at everything, the payload, and then it looks up that information against some kind of a database that the IDS has. So really, an IDS that is signature-based is made up of the sniffer part, which is just extracting the information, and then comparing that, you know, then it's, let's say, the logic engine. They have a logic engine, and I really should be writing this differently. So if you think about it, it's more like this, right? So there's the sniffer at the bottom, and then at the top there's some kind of a logic engine that compares to some database. So database of signatures. You see that? And then on top of that, there's an additional element, which is, okay, if I detect something, what do I do with this? And this is sometimes called the alert management. You know, because intrusion detection systems, and we'll see this later in the lecture, there's intrusion detection systems and intrusion prevention systems. But sometimes intrusion detection systems are just really after the fact. They don't stop any traffic, because there's implications about speed and everything. If, you know, imagine if a computer has to take a packet, take it all the way up here, and then let it go through. You know, that would be a very slow, and all of this is being done like on a CPU. It would seriously slow down your network. So there are issues with that. So it might be that it just lets the packets through, but it still triggers alerts. Okay, so. But anyway, that's really the discussion for the lecture. Really, today, let's just focus a little bit more on the lab. So in the lab, really, what we want to do then is we want to install, you know, have one server, right? So we're gonna start at the IDS. It's just a Linux server, and you're going to convert it into an IDS, and then you need to connect it into your network, your NAT network, etc. And then you're going to have some attacker. Now here, the goal is not so much, you know, succeeding. Let's say the target, the attackee is this one. That really doesn't matter that much, you know, because at the end of the day, you'd be sending a packet, right? So you're sending a packet as the attacker. It goes over there. But for this lab, what we really care about is that the IDS should detect it. Okay, so the IDS detects the attack. So the attacker is going to send these. And what are these? We've already learned the terminology. These are spoofed packets. You see that? So the goal of this lab will basically be, after configuring the IDS correctly, will be to be an attacker and spoof some packets that can trigger the alerts of the IDS. So we're going to reverse engineer this, okay? In the sense that what this lab, the way that I assigned this lab is that I'll show you there's a database. And we'll talk a little bit because the database has a specific formatting and language. It's all in Linux, so it's all text files, as you might imagine, but we still need to talk a little bit about how it all works. So you're going to find in there some signatures. Then you're going to try to create spoof packets that can trigger the alerts of the IDS. So that's your goal. So you're going to understand how the IDS works by spoofing the packets, okay? And then usually when you start the IDS here, you can have simply a terminal. So run it in the terminal. Run in terminal, right? And then, you know, whatever output you get, dot, you know, dot, 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 it'll say, so if you send an attack, let's say if you send an attack, right, and the IDS captures it, boom, you get an alert. Alert, you know, detected this attack. So what I need to see in the lab is the following. I need to see what your signature was that you selected, signature, and then what your attack looks like, so your spoof packet, and then evidence that you triggered the alert. Right? So you need to show evidence of that. Right? And that way, you know, again, you're launching the same class, same family of attacks that we've discussed in the previous assignments, but now we want to see how the sniffer part of the IDS captures it and deals with it. So remember, it's going through this whole pipeline of sniffing it. Then there's some logic that compares to the database. And then if there is something, what do you do with that alert? Okay, but we'll talk a lot, you know, in a lot more detail about those things in the lecture on Tuesday. So that's just the general scenario. That basically is, you know, before I go into the, sorry, if I, hold on. Before I go into the details now, this is the big picture, the general idea. So does this make sense, guys? Are there any questions so far? All right, sounds like there's no questions, so that's good. All right, so that being said, then that's the big picture. Okay, so hopefully you understand this one is not so critical, but you definitely need these two VMs, right? So VM1, VM2. Remember, at the end of the day, a router, whatever, you know, a Cisco router or whatever, a firewall, I want you to understand they're really nothing more than firmware. You know, so you can always think of any router as Linux. You know, you can turn a Raspberry Pi that has two network interfaces into a router easily, right? So it's not really an issue. Again, you know, that's one of the things that unfortunately we show you how to do in the lab, but we just don't have our Raspberries. But anyway, you know, just a Linux box of any kind with two network interfaces is a router. And if, we'll talk about this later, but if when we talk about IP tables, which is a topic we have to cover this semester, but and then the logic here, right, of looking at the packets basically means sniffing them. So any packet that goes through the network from one subnet to another would go through the logic code here that would sniff it and then do something to it. Either just pass it through the built-in firewall rules or actually send it to some higher end analysis like an IDS, etc. So really, I think intrusion detection systems should actually be called like analytical intrusion detection systems. So they're more than just that. And so we'll explore a few things. There's actually some nice companies out there that are really doing some interesting things with this. So if you guys are interested in this, check out a company called Blue Vector. They're a networking company, and they're really doing some very interesting things with intrusion detection systems. All right, so now that we've talked about the big picture, so this is the big picture, we can really now focus just on the details, right? So the way that I always do this lab is I provide, I think if I remember, it's just 3 classes of families of attacks. So the reason why I call these families is that there are too many individual attacks, right? There are too many. There are some like scanning attacks, and then there are SQL injection attacks, and then there are denial of service attacks, and then there are malware attacks. So but there's too many of each, and so therefore what I do is I think I just provide like 2 examples of 2 families of attacks. Okay, so 2 families of attacks, and then the third one I'm going to leave for you guys to figure out. So what I do is I ask you to pick one family of attacks different from the other 2 that I showed you how to do, and then that way I want to see you. I want to see you, figure it out. Okay. So ultimately, though, with every one of these, you need to create packets based on the signatures, in the IDS. So based on the signatures in the IDS, you need to spoof packets, and then the goal is for every one of the 3 attacks, obviously, I need the screenshot of, oh yeah, there's the alert. The alert. And what that means is that the intrusion detection system, if it sees that packet exactly as it should, it's going to trigger the alert. Keep in mind that for signature-based IDSs to work, the payload or the spoof packet needs to be an exact match. So signature-based systems are for what are called well-known attacks. Okay, they have a very good accuracy, very much like malware. So malware is very good at finding viruses that it knows, similar with signature-based, but it's not very good at finding new malware, right? In the same way that IDSs are not very good at zero-day attacks, okay, of that kind. We'll also in the lectures talk about how people create these databases of alerts, and that basically just, that might be a job that you're interested in someday, right? So becoming like an engineer for that. So you have to go in and kind of analyze an attack for several months, and then you figure out what were the characteristics of the attack, and then you establish a rule in the IDS itself that would detect that attack. Okay. All right, so this will be the goal of the lab. We'll come back to this, and I'll write it down obviously on the link. But for now, that's kind of the idea. All right, the scenario of this. So what will you use to generate the spoof packets? Well, you already have several tools. You can use netwalks if that's what you feel like using, or you can use so you can use netwalks to generate spoof packets. You already know how to do that. You can use C++ to generate spoof packets. You already know how to do that. Or you can use Python to generate spoof packets. You already know how to do that. So you have certainly lots of tools. If I were you, probably Python would be the easiest. And I'll provide some examples of that, but you already know pretty much. All right, so now I'll get into some of the details of this. Now officially, like formally, I'll get into the details. All right, so the first thing is, you might ask, okay, so on Linux, what are we going to use for an IDS? This is no longer just a sniffer. You want an actual intrusion detection system, okay, guys? So there's several ones out there that you can try if you'd like. And I encourage you to try other ones if you feel like it. Otherwise, there's one well-known one, which is called snort. There are some books about it. If you guys have an interest in that, you can always just check it out. Obviously, it's not required for the class, but there's a tool out there called snort. And it's basically a nice, simple little signature-based type. Later on, I'll talk about anomaly detection. That's a little bit more involved, obviously. So it's a little bit more complex. All right, so if this is the program, then what do you need to do? On the IDS Linux machine, what do? You go to the terminal. Now, keep in mind, you might need sudo privileges for this. So you would do something like sudo apt or apt-get, however you want to do that, install snort. Okay, so you want to install snort there. That pretty much should install the IDS. Okay. So an intrusion detection system, is a very valuable tool in the hands of an analyst. NIDS can analyze traffic in real time by logging packets on the network, and it will match your packets to a known set of malicious signatures, and then it'll trigger the alerts for the analyst to figure out what to do with the attacks. Now, snort has the advantage that it already comes. So one of the problems with these signatures is, like, if you go to like Cisco or one of those companies, they give you a few signatures for free. But the money that they make from those signatures. So what you might end up with the problem that you have to get a license, right? Because by having that license and paying for it, I don't know, monthly or whatever, you're going to then be able to download all the updated signatures that they're constantly working on. Okay, so obviously we don't want to pay money. Some of our Cisco equipment in the office, in the lab, have like 30 signatures. Snort has more. So one of the advantages of snort is that it does have several families, and they all come pre-built, and they're basically just text files that we can literally read them in clear text. They're not like binary or anything like that. So you guys can easily, and one of the requirements of the lab is that you actually read through those. Okay, you read through those, but I'll talk more about that later. So, so the snort IDS comes prepackaged with a variety of different rules or signatures capable of detecting different types of attacks. So, for instance, some of the database, let's say, of signatures has like things for reconnaissance, right? Reconnaissance there. Types of exploits, like buffer overflow types, right? So you guys, if you've taken the 450 course, you know what I'm talking about. So like buffer overflow. So if you've taken that class, you remember, for instance, that we talked about something called a NOP-SLED, right? So a NOP-SLED is a hexadecimal sequence of 90s. Now, if you see that in the payload, well, that's a NOP-SLED for sure. And a NOP-SLED is synonymous with a buffer overflow attack. So basically, your IDS should definitely scan the payload of your packets for NOP-SLEDs, right? That kind of, hopefully that intuition works for you to understand. Also, you might have signatures for denial of service, attacks, right? We've seen this denial of service attacks. Now you're going to see the other end of the spectrum on how these alerts look, right? So you're going to look at the defense. And that's really the goal of this lab, is that it's not so much the attack, right? You reverse engineer the attack from the defense, but really so that you can understand how the two relate to each other. They're nothing more really than if statements, right? So it's a whole bunch of if statements. If payload contains this, alert. That's really all it is. And this is just very few of the many families. So one of the things you'll have to do in there is really go and check it out, okay? Check out the different attacks, or signatures, sorry. Any questions so far, guys?
Nope, no questions.
So for instance, let's just say now, denial of service. So now in distributed denial of service, however you want to call it, that family of attacks will have a list of alerts. So, usually it's like in the text file, there will be rows. All of them are signatures. So you'll have in there, and the signatures usually have names, okay? So for instance, there will be, TFN, right? And then, you guys know in computers always have funny names like this, TFN2K, Trin 00. Whoever the engineers were that came up with these signatures, they always give it some kind of a name so that the attack can be referenced, okay? The Mitnick attack or this attack or that one, they're all in there. And so when you get an alert, you get a message that says TFN attack detected or Trin 00 detected. That's what I need to see when you guys trigger the alerts, okay? When you guys trigger the alerts, we need to see that output. So in the sense of reverse engineering, you will have to figure out, okay, what does a TFN, how can you detect a TFN attack? Which in essence says, what does the signature look like? And then the signature will say, well, the payload should contain these words, but also it should be a type of a TCP attack with these two fields set to this value and so on. All right, so it's usually like that. And it's, so keep in mind that we've already learned in the sniffing and spoofing labs that, the packet headers, right? Ethernet, IP, TCP, and then the payload, right? Or ICMPs, etc. So you guys know that all those fields could be relevant. And that's what you need to kind of understand a little bit better with this lab assignment. So when, let's say that you guys as the attacker use the TFN or the TFN2 or the Trin 00, you generate those attacks. Basically, it means you have to spoof that packet and have it contain all the fields that are required for the alert to be triggered. You will then send that attack, in a perfect world, right? Usually we have our network tapped at school. So you would send the packet to this machine, but in this lab, I guess since we're doing it remote, you can probably just I guess send it somewhere. The IDS is in promiscuous mode, right? It'll detect it. Obviously, another one is to send it directly to the IDS. That will also trigger the alert. Technically, it's a little less correct, but at the end of the day, it's about spoofing the packet that triggers the alert, right? So that you can understand this mechanism a little bit better. Because you will have total control of the spoof packets, right? You have total control, and you really will not be doing anything on the IDS. The IDS is just doing its job, but to create these packets, you have to look at to create those packets, you have to look at the signatures list in the intrusion detection system itself. Okay. So this, these attacks will trigger the alerts. And then, of course, what happens with the alerts, that's something that sometimes intrusion detection systems, if anomaly detection systems in particular, can generate too many alerts, and not every anomaly is an intrusion, right? So that's why at least signature-based systems have the advantage that when it triggers an alert, it's a real thing. So, you know, that's basically the idea. All right, so the next point, okay, so now once you going back to just the configuration, right? So you did sudo apt-get install snort or something along the lines of that, right? And then now your Linux machine is set up for that. So now where are the files? So you want to navigate in the file system, you know, and probably the files will be in etc snort rules. You'll have to check, like if you're using the 2004 VM, it might have a slightly different, I haven't checked yet where things are there, but it might be in a slightly different place. But usually they are in etc snort rules, and then that's it. So etc snort rules in your file system, after you have installed snort, which I don't know that it comes pre-installed on the CBM, so you'll have to double check on that one. But I've given you the command for it. Should be pretty easy. If you go in here, all right, CD in there, and then you do something like ls-l, right, you will get basically a lot of folders. And each folder will have the name of the family. Or it just might be a whole bunch of files with the name of the file, with the name of the family. So usually, for instance, it might be that it gives you ddos.rules. Okay, the extension, I believe, is rules for snort. And so these are files. Okay, so these are files. It might have another one, SQL injection.rules. And then it might show another one, malware.rules, and so on, right? So there's many of these. And inside each one of these files will be, in a text-readable format, the alerts in the snort language and basically the signatures themselves, which is really what you will need to explore to create your own spoof packets. Now, I will give you a couple of examples of how that works, but then after that, you have to create your own. That's really the lab objective. So for instance, if you want to look at one of these files, something like cat ddos.rules would be enough, right? So that would be enough for you to take a view, and then you can start reading through them. Also look at the slides on Tuesday that we'll discuss, and we shall see the syntax. But I'll give you right now kind of a picture. So let's say you did that cat command. So the output would look something like alert, because it follows this command type language where it says, okay, first I want you to alert. Alert on what? Well, if you detect an ICMP packet where you have an IP that's an external IP and you have a port number, or it could be any port number, and the direction is the packet is that way or the opposite, right? And then you have so the destination. So this is like the destination, and this is the source, or vice versa, right? And then port, and then after that you have the message that will be sent. So like alert, trin 00. So I detected that one, right? And then after that comes the fields that define the signature itself. So it might be that the ICMP ID, which we've already looked at in one of the previous labs, has to be 678. If it's not that value, then it's not this attack. Okay, for whatever reason, the people that crafted the attacks did it this way, or sorry, the engineers that researched it, right, figured out that all attacks related to Trin00 or TFN always look like that. And it has, the payload is called content. So the content has, oops, 1, 2, 3, 4. For whatever reason, that's the payload. All right, so packets that have that payload, that ICMP ID, and maybe some other fields will trigger the alert. And then after that, usually it has other parameters, like it might have a reference. And the reference just kind of goes back to some document. And then it might also have like priority. So you identify that this is a 4-level priority, right? You know, or something like that. Okay, so the language varies. We'll take a look at that in the slides, but this is the general idea. Okay, so if you do cat on here, you would get something that looks a little bit like that. And in the slides, I have, of course, like printed out examples of this, and so on. Does this make sense, guys, so far? All right, so there will be various signatures and these parameters will change depending on the type of an attack that you have, okay? So that's the first thing to understand. So you will look at it, right? You will take a look at those alerts. So now, the next step is, let's say that you have snort on, it's kind of already enabled. And now you want to, you decide, okay, I want to trigger the attack called DDoS TFN22K. So you decide, I want to trigger a DDoS attack called TFN2K. That's the one I want to trigger. All right. So if you want that, you have to find it in the signatures, right? You have to find it. You have to get that signature, what it is. Now, keep in mind, some attacks are easier than others. So I'm not saying necessarily find the hardest one and do that one, right? So you have to be, you know, you'll try a few and, you know, come up with your own, the one that you think that works. But once you know that you want to, that this alert, this signature is in the IDS, you know it's there as a signature, the next thing you want to do is you want to trigger that alert, right? So you want to trigger that alert. And so to do that, you will need to spoof the packet that will trigger that alert. That's really the trick at this point, okay? And so how do you do that? Well, you already know how to do that. You will write a spoof packet, okay? You will have to write that code, which by the way, you already know how to do, right? So how do you do it? Same thing. Let's say Python, which is probably the easiest approach, from, and this will be exactly the same script every time, minus, you know, you have to change the parameters related to the signature. So you have to do from scapy.all, import all. Okay, so you import all there, and then you're going to, you know, I would recommend creating a function. So let's say this is going to be my DDoS spoof. Spoof packets, right? So I need to trigger a signature. So then I'm going to say, you know, I'm going to set some parameters. So source, destination, the interface, if you want to provide an interface, and then the count, right? How many packets you need to send. Okay, so you define a little function there, then those parameters can be defined below. And then now, what do? Just like you did before, you need to create a packet. This is not sniff and spoof, right? So the advantage of this lab, at least, is that it's not a sniff and spoof kind of thing. It's a lot easier than that. You just create a packet, you already know how to do this, right? So you create the IP header and you will plug in the corresponding values. Then you figure out, well, if I'm trying to do a denial of service DDoS TFN2K, is that an ICMP? In this, you'll check the signature. In this case, it would be. So then it's going to be ICMP. And then again, the fields, right? So set up the appropriate fields based on the signature, and then the raw, which is, load. And again, let's say 1, 2, 3, 4, whatever, that also comes from the signature. These parameters are the ones that come from the signature. Well, the idea is because you want that packet to be detected and trigger the alert. And then that's it. That's literally it. Then you just do send. And what do you send? You send the packet. And it's as simple as that. Questions? Now, the last part is, once you have snort initially and you turn it on, it's not on by default, okay? So it's not on by default. So you have to kind of turn it on. So you would go to your machine, either sudo or let's say you're a root, and then you're gonna do snort. Usually like -Q-A, some flags. You tell it console. You tell it to lock on to your ENS33, whatever your interfaces are. And you tell it to load the configuration files. So usually it's going to be etc snort snort configuration. This may change, so you'll have to double check. But usually that command will start the snort sniffer. So at that point, the terminal just kind of hangs there and it's listening. It's listening for traffic, okay? Very much like any other kind of a sniffer. And then now you need to, obviously, if you tell me on the lab, okay, I'm doing TFN2K, right? I'm doing TFN2K. Okay, it's an ICMP DDoS attack. Okay, great. The signature looks like this. That's my script over there. And then I'm going to make sure the snort is working. So snort is listening on the network, right? And then now you launch this, you run your script, send the packet, maybe show it in Wireshark if you'd like. And then here, you have to trigger the alert. What is it? TFN2K. So I need to be able to see that TFN2K, whatever, that that attack has been detected by the intrusion detection system. And it's really that simple, okay? It's really that simple. If you get any errors, like if you get any errors when you run this command, it'll tell you something in the output. Check. So this sometimes gives an error, but I think it's been fixed over time. But there used to be an error in the loading of the file. So if it gives, so pay attention to this. If it gives you an error, pay attention to what it says, what file it gave you an error on. So go to that file, and usually there, the message may say, error at this line. So if it says something like error, where you have something like this, DNS, something like that, you just have to comment it out, basically. So put a pound sign in front of it. Don't delete it, just comment it out. That should take care of the problem. Okay, so that's only if it happens. All right, so that's basically for today. I really just wanted to give you kind of a big picture of this lab. Next week, we'll do the lecture, and then I'll provide more information about it. But hopefully by now, you have, for those of you that have already submitted their TCP/IP attacks, you can get started on this one. And then we will just continue intrusion detection system discussion on Tuesday with, you know, like more formally with the lecture approach. All right, so that's that lab, intrusion detection. So in the time that remains, what I'm gonna do is I'll stay, I'll stop the video now. I'm not gonna give any more content. Let me stop the video.